welcome everybody to our webinar dedicated solutions for AI in AWS. My name is Hubert Pułacz and I'm AWS Solution Architect. With me is a great specialist from MLOps Engineering, Christian Kozio, and we have a pleasure today to present to you some solutions regarding custom AI models for your data. Yeah, let me change the slides smoothly. We are working in Millennium for a few years, and we are focusing on preparing the solutions for our customers in MLOps and AWS. So, agenda for today is we will talk a little bit more about SageMaker. Christian will introduce us into the SageMaker on AWS. SageMaker Studio. We'll talk more about going through the full machine learning lifecycle from data to working models, because it's a clue of our webinar today. We'll talk about MLOps a little bit and cost optimization and the way of deploying of our models. So I think we can start. For the beginning, few numbers now. Oh yeah, they are showing now. Yeah, so starting from the numbers, we experienced explosive growth of the AI market in 2020 and 25. Now it's worth about $244 billion in the globally, and there is invested $107 billion already in AI in startups. It's a year over year. There is a very much growth through that time. And we can see that a lot of companies already using or exploring AI, and there is almost no one that is not using, and almost no one that not knows the OpenAI, ChatGPT, and other solutions for AI. So we have great expansive of that solutions, and we can see that AI represents almost 26 of all global VC funding. So the numbers are totally big. So, and we have, we can see that the market is still growing, and AI training data set, but AI is fueled by the data. Without data, there is no AI. So the AI training dataset market now reaches in 2025 about $3.5 billion. It's a completely huge, expansive growth through the years, and we need to have data for training more and more to have newer models and so on. And there is a data scientists are starting to use synthetic models. There is a synthetic data revolution because we need more data. So now 60% of all data just comes from the synthetic data. What does it mean? It's just the data that are generated. They are not real, but they are, for example, neural networks generation or just anonymized from the world, and data creates data. So data are needed for training the models, and the models for AI are generating more and more data. And in North America, there is almost 50% of global market share that Gartner predicts by 2030. Synthetic data will dominate AI models. What are the leaders in that sector? We have audio, image, video, and text dominance, and we can see that telecommunications and automotive and healthcare gives us the fastest growth in the world. However, many leaders in IT notice that there is a AI skills gap in the companies, and 42% of organizations worry about data privacy issues. That's a very good behavior, because we are more and more aware about the danger of using AI without any reflection. And however, only 37% of companies track data provenance. That still is to be improved for us. And the basic question is, why do we need the custom models at all? First of all, because we just have OpenAI, we have the ChatGPT, we have Claude, we have many others, LLMs, Llama from Meta, Mistral, and so on. And you can use just these foundation models. However, in some cases, you need the unique data for your industry. For example, medicine, finance. For example, you would like to specifically calculate the mortgage for your customers, or you need high precision for your requirements. Now, foundation models give us about 70 to 80% of accuracy. But if you need more, that is 95% of accuracy, you need definitely the custom models for yours. Once you are touching the regulatory compliance, if you need to be compliant with some regulations, then you need custom models. If you have proprietary data, then you need custom models. Or if you have other specific use cases, then I bet that you need custom models, and the next slides will show you how you can use them and how you can train your data very smoothly, quickly, and deploy them even immediately. Yeah, so the main difference between foundation models and custom models are that foundation models are just right now, right here, we can start them, start using them. There's a quick deployment, low initial cost, because we are getting from the marketplace, from the places that are, for example, Hugging Face, and there is a ready to be used. However, disadvantages are that there is a general application for that. I said about accuracy. There is a big disadvantage when you need more accuracy for your cases. No data control, because the data, the LLM in foundation model is just a closed model. You need to do fine tuning, or you just can't do nothing with them, because it was trained on some data that are not yours. And that's why we have some potential IP issues that still is under discussion. However, what about custom models? What are their advantages? There's a high precision, full process control. It's a end-to-end, completely yours, data sovereignty, intellectual property ownership. However, it takes longer to develop these models, and it may sometimes increase the cost for initially. So that's why many people are starting from the foundation models and then going to custom models if their requirements are not met. And I will pass my voice to Christian, that he will show you more about the life cycle for the models, and we'll go to SageMaker AWS directly. You're muted, Christian.
So as Kubek said, what is very important is that custom models are often required for the environment that we are working in and for the problems that we are solving, because general models are adjusted to, well, general problems actually, and they are not sophisticated enough to cover everything that we are doing. That's why we need to train models. And to do that, we need first to do a few things to even start thinking about that. So first of all, we need to have a data. Once we've got the data, we need to engineer our features. And to do that, we are processing the data, transforming the data, making sure that everything inside of our database is properly processed in a way that all of the correlations are founded, basically. So we are not using the same data, the same information twice. We are trying to normalize the data in a way that everything is in the same schema and range. Because, for example, when we are talking about real estate market, we've got different numbers that, like, for example, this square root the meters of the apartments, for example, and the cash amount needed to pay for that. They need to be put into the same perspective, because our model will learn that the bigger value means more for it, and we need to make sure that it's not really the case. Once we've got the data covered, once we've got it normalized and adjust to our problem, we can start the training. And when we are starting the training, we start thinking small. We are starting with some statistical models, then we are going into deep learning, and eventually we are going into the more sophisticated solutions. We are checking what is the state of the art in our problem at the market, and maybe we are building our own solutions. It really depends. If we've got a lot of data, we need probably more complicated models to understand better the patterns that are in our data sets. That requires more computational power. We might think about hyperparameters optimization and maybe adjusting our training in the way that it's, first of all, finished in manageable time, and second of all, it is not too expensive to provide the model, because we might spend months training the models, like organizations that are focusing on that, like ChatGPT, OpenAI. They are spending billions to train their new models every year, and that's something most organizations are not able to cover, and they need to basically optimize this process. Once the model is trained, we are happy with the outcome of it. We need to deploy it. There are multiple options as well to do that. Sometimes we need our data in real time, so we need answers in seconds. And for that, we need some real-time endpoint. We need to optimize the model. We need to optimize the solution that is serving it. Sometimes we need the reports that will basically show us the predictions, so we can live with batch transformations. We are passing the batch of the data, I don't know, Excel, for example. It is processed by the model, and it returns the predictions for each of the rows separately, for example. Or we need to have multiple models to cover more complicated solutions. Like, for example, in pharmaceutical industry, we are talking about multiple different problems at the time. So, for example, when we are talking about drug discovery process, we need to talk about toxicity, about the complexity, and about the different parts and different coverages of metrics that are required to make sure that the health is in a proper way managed by our model. We need to have a lot of insights, and in that case, we might need multimodal models that basically will be multiple models served in one endpoint. This is something that can actually be done with usage of Amazon SageMaker. Amazon SageMaker is a fully managed service that can be treated as machine learning platform, and in most cases, it is sufficient to cover all of the needs in organizations that are building machine learning models. It is part of AWS ecosystem. So if somebody is using AWS Cloud, I think it's natural way to use SageMaker, but if not, it can be treated as external platform. Data scientists that are using it don't really need to interact with the infrastructure that is under the hood managing it. So managing it is always the hardest part, and we just need one person that will manage the infrastructure for us, and the team of data scientists doesn't really need to understand what is going on under the hood. And there are multiple different options, multiple different services inside of this platform that we can use, and that are helpful from the perspective of data scientists. So we've got SageMaker Studio, which is basically integrated development environment. It is a notebook platform, basically. It's laboratory that data scientists can share across themselves. They can work on one files that basically is the model training. They can share with themselves their data analytics, so everybody can be on the same page and that they can collaborate there. We've got training jobs and data preparation possibilities that I covering two of the topics I mentioned at the beginning. And we've got possibility to host the model through real-time inference or batch inference. That's something that I've mentioned as well is needed at the end. And we've got the possibility to automate. That's something I didn't mention in the previous slide, but once the model is trained and ready on the production environment, we as data scientists tend to forget that our world is changing, and our data, due to these changes in the world, might often differ in a time. And there is something that is called data drift. So basically the drift of the data in the time where some event, some behavior of the client is changing, and that we might not really understand why it is changing. But our model, if it's trained on the data from last year, it might not be sufficient enough for the next year. And we need to retrain it, basically, gather the data, do the processing of it again, and then train it. And to do that, we've got MLOps pipelines that are basically workflows that are super easy to enable, and we can, as an owners of the solution, use them to automate the process in general. SageMaker Studio, as mentioned, it is great for collaboration. Other than that, it provides us with some add-ons like integrations with Git and all of the ecosystem in AWS. It is easy from the perspective of model owners, and what is important is that each project can have its own studio, so we can have all of the data scientists across the different AWS organizations. Even they can use one SageMaker instance and have access only to the projects that will use under the hood some machine to run the notebooks. And this let us manage the cost in a better way. So basically we can use small machines for the development only, like T3 Medium. That is, I would say, standard way to start your collaboration with other people to prepare the data and make sure that everything is set as expected. And once we are going to that stage of training, we can use a much more powerful machine, like for example P3 machine, which provides us with a GPU support and let us train the models with usage of GPU, or even P4D machine, which is used in large language models training or fine-tuning, which basically give us a high performance, let us use 160 or 320 gigabytes of video RAM, and let us load the bigger models, even like Llama 70 billion parameter, which are multiple gigabytes models into the memory. So that's when we are using machines that are costing us almost $40 per hour. When it comes to the data preparation, AWS provides, with SageMaker, there is Data Wrangler provided. That is a no-code data preparation tools that let us build ETL workflows, visual the data, and in general generate the scripts for the processing in a pipeline later, in a very easy form from the data scientist perspective. A lot of data scientists don't really need to understand big data processes, and which is fine actually. I mean, we've got other roles that are covering such parts in a lot of organizations. But if we don't have such role, We can do it in a semi-automatic way, so we can just drag and drop the different operations that needs to be done by our ETL script, and AWS is building AWS Glue job. That's a service that is used. It is Spark based job that later can be triggered by our model, by our pipeline or by our process. So at scale, we can use this tool, this data wrangler tool, as it's using Apache Spark under the hood, which is a big data tool. So we can process actually terabytes of data in minutes, which is actually great. So from a lot of organization, that is enough, and we don't really need to worry about the outcome. At the end, we've got custom Python script that can be run everywhere. Eventually, we can build our own custom logic manually with Python, R, or any other tool like Scala, then pack it into a container and run it in our platform. So that's something we can do as well. And if we've got proper big data pipeline, ETL pipeline, some data lake set in the organization, it is really easy to integrate with Amazon SageMaker. So what is important as we've got possibility to run custom models, but when it comes to custom models, we can actually treat them as two. We can actually separate this category into two subcategories. So there are built-in algorithms. These are algorithms that we can use directly on the platform, and we don't really need any additional preparation to run them. So we can use XGBoost, factorization machines. We've got some image classification services, semantic segmentation processes, some random forest, and so on. These things are provided by AWS. So classical machine learning problems can be resolved with the services provided directly by AWS, and they are in a state-of-the-art manner. So basically, they are guaranteeing the similar outcome as with usage of state-of-the-art solutions that are available across the internet and that are open sourced. They've got probably a better quality, but it is at least as good as what we can find there. But sometimes these solutions are not good enough for our problem. Sometimes we've got very custom issue, like for example, we don't need to classify an image or detect an object. We need to detect the object that can be harmful for somebody, or we need to detect information about the, I don't know, sign on the road that we are passing, and our computer in the car needs to understand it. And in that case, we can bring our own solution. And again, there is a support of all of the most common libraries across the internet. So TensorFlow, PyTorch, scikit-learn, MXNet, and Hugging Face. These solutions are all supported. AWS had some agreements with Hugging Face and PyTorch, for example, to provide their trainers and basically set it on the platform. In case we cannot use any of these frameworks, so we need to have super custom solution written in different language than the standard machine learning solutions, we can use our own containers. We can build Docker container that will be supported by AWS. That's basically how it is done most of the way. And in case of the training, we can parallelize the data processing, parallelize model processing, and eventually the pipeline that we are building. We've got support for all of the parallelization methods in TensorFlow and PyTorch, and we can scale our training horizontally and vertically, depends on our need and requirements. But from our perspective, it is always, well, easiest to start small. Try to maybe use mixed precision if that's a possibility. Depends on the problem, of course. It might be, especially in inference serving at the end. It might significantly speed up the process, but well, how to do that is really up to you. And well, from our perspective, it's always best to start small and then expanding, because this way you can save some cost and headache at the end of the day. And what is quite interesting, and what I would like to show you as well during the demo in a minute, is that there is something called autopilot in SageMaker, and this lets you automatically tune your hyperparameters. So it provides a few tuning strategies. AWS is automatically choosing the proper strategy for you. Normally it is starting with Bayesian strategy, but you can specify other like grid search or random search, which might be better for your use case. It's always really require you to understand a little bit better your data and how your model is trained later. And you can, well, it is optimizing the parameters for your model. So basically, if we are talking about neural network, it is optimizing the number of layers, the batch sizes, and the regularization techniques are used to basically train multiple models and compare which of the model is the best. And well, AWS is doing it in automatic way, and at the same time it is not training like 10 different models fully and then compare. It is comparing on the fly how your models are behaving, and is stopping each of the model that is not really meeting the requirements. And at the end, when the requirements are met, it is cutting off the unnecessary computation. So basically, in this manner, you are saving quite a lot when comparing to doing it by yourself. Right now, I would like to show you a demo. Let me stop the presentation and let me show you how SageMaker Studio looks like and what you can do there. So as you, is my screen visible?
Yeah, yes.
Awesome. Thank you, Hubert. So basically, that's a main view of SageMaker Studio. As you see, right away, I get information on where to start my build when it comes to machine learning. So if I want to build machine learning application, I will create the notebook. But if I want to build Gen AI-based application, use LLM, I can use directly Amazon Bedrock and build chat agent there. I can process the data, I can do governance, and there are other options, like, for example, get into Jupyter Lab, so that's the same as going there. Go into my data analytics tool, orchestrate the data, the workflows and ML pipelines, develop the model, and check what are the processes that are running on the platform. Eventually, I've got some model registry, I've got some application development techniques with the usage of Gen AI tools. There is Amazon Q, there are other things that we will not cover today. They will be covered in other meetings in the series that we are starting right now. But first of all, I've mentioned the first process is always data analytics and integration. So let's go there. Let me just open my project. And as you might see here, we've got the information about the lakehouse. AWS is always trying to use the lakehouse as a main data source, and that's based on AWS Redshift or and it is using the AWS Glue as the workflow to create your ETL processes. Or eventually you can use Amazon Athena to run your SQL queries. So here I've got some data in a default table that is a join data churn data is one of the most popular data sets in the internet, I would say, in machine learning world. I think that everybody had some exposure to that, because this data set contains information about telecommunication company that is trying to predict if person will stay with them or if person stayed with them or left the company, and try to basically keep them around by providing some additional abonnement options, like, for example, additional minutes, additional internet package, and so on. So basically, we can get through the data and understand what is there, and we will have information in SQL table, SQL view at the end. Other than that, we can change to chart view, and in chart view we can get multiple traces at a time. We can change the style and annotate our view, so that can be used by everybody to take a look into the data. So, for example, right now we've got just an information about the state and how many people are in each of the state, how many. But for example, I can check how many minutes used at night. So how much people are talking at night, and how much this is really changing our how many people stayed when talking at night compared to the people who were not doing that. And as you see, it is very similar. So they are not really this data is not really changing much the decision. Let me maybe change the axis. I will use churn here, and here we will use other information, like, for example, minutes used during the day. And as you see here, when people were using more minutes during the day, 5 and more, they were more likely to stay with the organization, with the telecommunication organization, compared to the people who are using less of them. So yeah, this data set is, as I said, is quite common. You can find multiple different analyses there, but there were some columns that have a high correlation with the outcome, and they need to be used in the process of training the model. But once we've got this analysis done, once we understand a little bit better what is happening and why some decisions were made by the people, we can go into the model training process. So we can start our journey of data preparation. But actually, this problem contains tabular data that is quite easy to follow, and we can use the autopilot that was mentioned during my presentation. So I can show you that we are downloading the churn data. We are training the model with some fractions. So basically, we are taking 80% of the old data to the training process, and we are preparing the test data. Once it's done, we are loading this data into auto machine learning job. And auto machine learning job is one of the services provided by SageMaker. So I am using the SageMaker library here, and I am using create auto machine learning job, which basically takes input data and output data and is doing the process of the feature engineering and model adjusting in the automated manner. So what is happening there? First of all, there is some data analytics process that is happening. Later, we are doing the feature engineering. The SageMaker is actually doing feature engineering for us, and it's tuning the model. After that, we've got the report that we can take a look into, and we can understand better what is happening. Once this process is done, we've got two artifacts that are quite important for us. So we've got notebook definition, candidate definition notebook, and data exploration notebook. And these two notebooks can be used from the perspective of a data scientist to understand why certain decisions were made by SageMaker. So this helps us to explain to the business why certain process happened and what was it based on, basically. And in certain areas like security, banking, pharmaceuticals, it is super important to have this information. As it's from the regulatory perspective, you need to have such understanding of the process made. Once it's done, and once we've got we can check what is the understanding and what is the precision of the model. There are multiple metrics we can use, and for such issue, precision is quite common. And as you see, it's 93%, almost 94% of the precision outcome. And for IOC, which is a combination of multiple metrics, we've got 98%, which is really good. And as I said, the data set is well known, and every model is adjust to it. So from our perspective, and the data is pre-selected, so that's why these values are so high, and that's why this is basically the production grade solution. It is making less than around 5% of the errors. So it's not really that bad. And for such a case where we want to provide the better service or some kind of bonuses for the people who might leave us, it is a super helpful outcome that we've got here. Okay, so this is AutoML, and I've showed you more or less how it's done in quite quick manner. But as mentioned at the beginning, we can run models that are basically custom, and to do that, we need to have some training scripts written with this with the framework that is interesting for us. In this case, we've got JAX framework. That is the framework that is basically the wrapper for some of the TensorFlow methods, which let us build machine learning model in some specialized manner. So basically, JAX is another framework that was built on top of other, and it let us build machine learning models in an easy manner with usage of the JAX, with usage of it and with usage of the method that it's providing. And what is happening here? We are building the class of JAX NIST, which is NIST is one of the commonly used commonly used data set that contains information about the size of the flowers, as I remember. And it provides us, we need to provide a method like prediction, loss function, accuracy, and training method that will basically let us build the model. And based on that, we can train the model using the using the custom solution. So we can later get our model into such manner that we've got the builder. In this case, it's TensorFlow builder. We are providing information which script should be used and what is the source directory for the script. And our model is building the training job. Training job can be found inside the model development tab. And there is information about the process of the training job, what is the outcome and what is going on there. I see that I've got a problem with accessing this tab right now. Well, that's a live demo, so sorry for that. But once the model is trained,
yeah, if you have any questions, you can ask on the chat Q&A, and we will answer after the whole.
So sorry, once the model is built, we can expose it using a create inference method from SageMaker, and it will basically expose the model with some internal URL. All of the models in SageMaker are exposed internally. They can be accessed only from the account, and to expose it to the external world, we need to use API gateway or some kind of a Lambda, and that's something that is the design from AWS, so they are not freely available across the web, and nobody can use your data or your knowledge that is saved in the model without you exposing it and then securing it. Okay, I think that's all about the demo. We've spent quite some time there, and I think we should move to the next topic. So thank you.
Thank you, Christian, so much for that presentation. I hope that you see the value in using SageMaker, and let's continue the presentation now. Present. Let me allow to present. Okay. Yeah, I'll get back to the slide that we finished. Exactly, it was here. Yeah, so Christian showed us that we can have the whole pipeline regarding model data preparation, model training, and model hosting, and the model deploying. So I will talk more about costs and optimization that we have there. So just for some reminding, we have a SageMaker model registry that we can versioning our models for saving them for later to have integrated with CI/CD. That's very great. And deployment options that we have in the endpoints. And what are the endpoints that we can deploy a way of? So we have three types of deployments. We have real-time endpoints. If you need significant latency for your case, you can use real-time endpoints with auto-scaling, A/B testing, multi-model in one endpoint. You can have also a batch transform if you're processing a bulk of data, even terabytes of your data can be processed simultaneously. We have scheduled jobs. We have no infrastructure management, and there is also serverless inference for the smaller models because it's a little limitation in that your model cannot be bigger than 10 gigabytes. And we need to think about cold starts because serverless is just without infrastructure that we manage. It's managed by AWS. So if you consider that way, remember about the cold starts because it's starting from zero. What about multi-model endpoints for cost optimization? You instead of having multiple models, multiple endpoints per model in one image, you can have one endpoint for multi-models that gives you even 70-80 cost reduction versus single endpoint. You have a dynamic model loading, so you have a central management, shared compute resources. And if you have 100 of similar models, please remember that you need to use the same architecture for that. And models are used sporadically, or they are smaller than a few gigabytes. You get benefits from A/B testing. And remember that the maximum models that you can put there is about 1,000, and still the cold start latency for new models is present. Another thing, maybe another possibility is to asynchronous inference for unpredictable traffic. If you don't know how much computing you need or how much traffic, or what it's irregular, you can choose the asynchronous inference for your models. It's just very simple steps that you send a request, it's stored in SQSQ, it's processing asynchronously when resources are available, because you need to know that in the cloud there are a lot of resources in multiple availability zones in regions. However, not so much that we thought, and sometimes we experience a lack of resources in one region or another region. So we need to consider that. That's why we use asynchronous inference sometimes for results to be saved to S3 bucket after all. And that's for our when we need to long inference times, large payloads, and queue-based workflows. So I think this is the best choice for these that I would like to optimize costs. And remember that in AWS, you are paying only for processing time or for usage time. There is no subscription in upfront, apart from some use cases. I will talk more in a minute. For monitoring our models in production, we have a great tool that is SageMaker Model Monitor. So SageMaker is just a set of tools that it provides you the whole platform for pipelining, for preparing data, and for monitoring as well. So if you would like to monitor data quality, data drift in your organization, in your models for model bias, that is may challenge the decisions, and model explainability, please choose the SageMaker Model Monitor that can help you fine-tuning and training more reliable models for your cases. A/B testing for machine learning models, it helps you for very quickly testing which model is better. So you can deploy just a blue-green A/B, right? You can just deploy one model that is the primary one and the secondary one that you would like to challenge. With some testing strategies, you can use canary releases. So the traffic is going from the primary model to secondary with some traffic increase. You can have blue-green, just a quick switch. You don't need to wait for deploying the second model a few minutes. It's just a very quick switch. And you can track multiple metrics there, latency, error rate, throughput, conversion rate, revenue, user satisfaction. And if these metrics are not you are not satisfied with the metrics that you see, you can just do the rollback for the previously primary model. So it's a great option for these that would like to challenge the models and choose the best one. What about cost? Because we know that in the cloud we are paying for everything. However, we can pay less with smarter decisions. The breakdown is very simple because we are paying for training costs, for hosting costs, for studio, is just the platform, and the data cost. And these costs are, as I said, pay as you go. So you're using, you're paying. You are not using, you are not paying. And you can choose the computation for many EC2 machines that are available. You can hosting the real-time endpoints, serverless endpoints, and batch transform. In the AWS calculator, you can calculate granularly the cost for your case. So this is very great that the tool is provided for checking, for forecasting how much you will pay in the future. And if you need more computing power for deploying your models, you can just start using auto-scaling endpoints. So we have minimum 1 instance per endpoint. However, you can have more. Maximum number is 20 in SageMaker endpoints. You can set up sorry, just an example. You have much more, but in example, we have minimum instance is that you must have a minimum one instance. It's the difference between serverless model that you are scaling to 0 and the endpoint, real-time endpoint that you must have at least one. If, for example, you are setting the target CPU for 60%, and when the CPU computing power is reaching that the target, it's scaling out. If the target is below, it's scaling down. So it's very cool for adjusting the computing power for your models. So you have multiple scaling metrics that you can use: CPU utilization, memory utilization, invocation per instance, or model latency. If the model latency is differs, then you just run the auto scaling. It's of course for cost optimization, because sometimes we don't need to you don't need to run a super big machine for your models, for hosting your models or for inferencing. You can just run the auto scaling, and for peak hours use that computing power, and after peak hours it will scale down, so you are paying less. Spot instances, a very great possibility to decrease the cost and save some money. The spot instances are just a free available computing power that are some like in a marketplace. They are offered with a lower price. However, they have one disadvantage, that they are available only for some time. So after some time, they are terminated and get given back to the pool that are available. However, you can use them for training your data, for inference, and this interruption rate is very small, and it's worth for using it. Maybe in production you need to be careful. However, you can decrease your cost even up to 90%. So the savings are very great. If you calculate and you claim that is too much expensive, just consider spot instances, and you'll see how much money you can save. As well, reserved instances are very great for hosting your models. If you know that you are sure that if you are 100% sure that you'll use this machine for inferencing, for training, you can just make a commitment for that machine for 1 year or 3 years, and you can pay for that more and more less than normally. For example, on demand, it's just yeah, it maybe cost even $1,000 per year, and with a commitment for 1 year or 3 years, you can pay even 60% cheaper. There are 3 possibilities for paying. You don't need to pay anything, just a no upfront, so you're just starting using, and of course is the most expensive one. The partially upfront, you are paying just you do some capex, so you make an investment partially, or you can pay just at once. So this is the most cheaper way for having the instances for a long time. And integration with AWS. We know that SageMaker is a part of the AWS cloud, is a platform that is fantastically integrated. You can host model on S3, you can use data from Redshift, from RDS Aurora, you can store the data there, you can use ETL services like Glue, you can make business intelligence with QuickSight, you can stream data with Kinesis, you can use API gateway for reaching your models privately or publicly. You can use Lambda for some custom integration, step functions, event bridge for event storming on event-driven architectures. Of course, as well for DevOps integrations, code commit, code pipeline, CloudFormation, and CDK are very great for setting up the infrastructure as a code with your training jobs and with your training notebooks that you don't need to click every time, but you can set it up somewhere in scripts, and you can run once it's needed, or you're setting up the new account. So it's very important to remember that SageMaker is integrated with a lot of AWS services that you can use out of the box and seamlessly connect them and start using. And for the end, just almost the last slide, I would like to pass you some hints, best practices, what to do and what we should avoid. So yeah, as we said during that time, start with a small prototype, scale later, because sometimes I see that people are preparing a very big project without POC, without even testing, and they are paying much more than they expected, because even anytime it's just, I think that just a general hint that we need to prepare something small for adjusting later and see how the costs are there for us. Use spot instances for training, for getting the savings. Implement a proper monitoring from the beginning. It's important to have monitor all the time. Sometimes people say that, oh, I don't need monitoring for now. Yeah, you need, because even you don't use now, you will see later how it was on the beginning. Your metrics, how were your metrics. Version control, automated testing, regular model training schedule, so that your model is always up to date. Have a versioning for yours in the model registry. And what is very helpful, tag resources for cost tracking. And you can, in Cost Explorer, you can see on the dashboards divided by tags what resources cost how much money. And regarding don't leave idle instances running. You can pay much, of course. If you want, you can set up automation for switching off the instances in an idle time when you don't need the machines. Don't use oversized instances. If you really have development, you don't need just a P424X large machine. You can just start smaller and adjusting to your needs. Do not skip border validation. It's a very common problem that models are not being validated before going to production. Do not ignore data drifts, because it may lead to some problems that Christian already said. Do not deploy without testing. I think that's clear. Do not mix production and development in the same account. It's a best practice in AWS to splitting the production and development. And of course, I think that we know all that. Do not store sensitive data unencrypted. We have a few services in AWS to encrypt your data and keeping them safe. And the last slide, what are the trends in the future? I think there are some news in AWS SageMaker Studio for upcoming features. However, I would like to point to your development, your companies, that I think you should definitely invest in your skills if you don't have still. AWS have two certifications in one in AI, Cloud AI Practitioner, and MLOps Engineering. These certificates are started just a year ago, and this is quite new. So it's a great possibility to catch up the things on your skill matrix in your company, and hands-on workshops and labs that are available from AWS. If you would like to talk more about AI and deploying custom models for your company, for your organization, reach out to us, and we have the pleasure to cooperate with you and talk more about your cases, your problems, your challenges. If you have any questions, you can use the Q&A channel. However, I see that no questions for now. This meeting will be recorded and sent to you. So thank you so much for attending. I hope that this time was very valuable to you, and we passed some value. We brought some value to your technical life regarding AI and training data. Very much I enjoyed with that time with you. Thank you very much, Christian, for presenting. So yeah, this was the first webinar in our series. If you would like to see the next ones, you can follow our profile on LinkedIn, on our website, and do not and remember to save your dates for the future. Now, thank you so much and have a great day. Bye.
Thank you. Bye.
Millennium. IT for people. People for IT.